Hello viewers, in today's session we are going to discuss the solution of this inequality where we have mod of x plus 4 greater than and equal to 2x minus 7, right? So let us see how we can find out the solution of this inequality using the definition of mod function, that is the absolute value function, and then we can make use of the method of intervals, right? So let us start and let us first define modulus function. So now we can define a mod function. So mod of p is defined as positive p whenever p is greater than and equal to 0, and mod of p is equal to negative p when p is less than 0, right? So here first of all we'll define mod of x plus 4. So mod of x plus 4 can be defined using this definition. So we can write mod of x plus 4 is equal to positive x plus 4 whenever x plus 4 is greater than or equal to 0. So from here we can write x greater than or equal to minus 4, and mod of x plus 4 is equal to negative of x plus 4 when x plus 4 is less than 0. So here we can now write x less than minus 4, right? So now here we'll consider two cases, right? So the first one is when x is greater than or equal to minus 4. So now here we have the real number line. Here we have minus infinity, here we have plus infinity, and here we have minus 4, right? And here x is greater than and equal to minus 4. So here a minus 4 is also included, right? So when x is greater than or equal to minus 4, we can replace mod of x plus 4 by positive x plus 4 in this inequality. So now this inequality can be written as positive x plus 4 greater than or equal to 2x minus 7. So now we have a simple linear inequality here. So we can solve easily this inequality. Taking 2x to this side, we have x minus 2x, and then we have minus 7 and minus 4, right? So x minus 2x is minus x, and here we have minus 11, right? So here we can now multiply both sides by negative 1. So we have here positive x, and here we have positive 11, but the direction of the inequality it gets reversed. So when x is greater than or equal to minus 4, then this inequality gives us x less than or equal to 11. So now let us represent 11 on this real number line. So here we have 11, right? So now here we have x greater than or equal to minus 4. So the region represented by x greater than or equal to minus 4 is given by this region, right? And remember here we consider minus 4 also, because here we have the equality, right? So x greater than or equal to minus 4 is represented by this line, and x less than or equal to 11 is represented by this line. So here 11 is also included. So we can have x less than or equal to 11. We can represent it like this, right? So here the common region represents the solution of this inequality when we have this condition, that is x is greater than or equal to minus 4. So now this is the common region which is given by these two inequalities, that is x greater than or equal to -4 and x less than or equal to 11. So this region is common to both these inequalities, right? So the solution of this inequality when x greater than or equal to -4 is given by x belonging to this interval, that is -4 to 11. And remember here, -4 and 11, both the endpoints are also included. So here we have a -4 and here we have 11. So now let us consider the second case when we have x less than -4. So let us again draw the real number line. So here we have minus infinity, here we have plus infinity, and here we have a minus 4, right? So x less than -4 is given by this region, and here we draw a circle which represents that -4 is not included, and here we have drawn the dark circles which represents that the points -4 and 11 are also included, right? So when x is less than -4, then mod of x plus 4 is given by negative of x plus 4. So now replacing mod of x plus 4 by negative of x plus 4, so now we can write this inequality as negative of x plus 4, and here we have a 2x minus 7. So now we can easily solve this inequality. Here we have minus x minus 4. Here we have 2x minus 7. Now we can rearrange the terms. So we can take 2x to this side, and here we have minus 7 plus 4. So this is minus 3x, and here we have 4 minus 7 as minus 3. Now dividing both sides by -3, we have here x, and here we have 1, but the direction of the inequality, it gets reversed. So now when x is less than -4, we have x less than or equal to 1. So let us now represent this point 1 on this real number line. So here we have a 1, right? And here a 1 is also included because here we have the equality, right? So x less than or equal to 1 is given by this region, because here we have 1, and x less than or equal to 1 is given by this region, right? So now x less than -4 is represented by this region, and x less than and equal to 1 is represented by this region, and here we have the dark circle which represents that 1 is also included. So now the solution of this inequality is given by the common solution between these two inequalities, that is x less than -4 and x less than or equal to 1. So from here, these two regions, we can easily identify the common region. So the common region is this one, right? So the solution is now given by x belonging to the interval that is from -infinity to -4. And remember here -4 is not included, because in this inequality -4 is included, but here -4 is not included. So we have x belonging to -infinity to -4. So now from these two cases we have two solutions, right? And the complete solution of this inequality is given by the union of these two intervals. So now the solution of this inequality is given by the union of these two intervals, that is from -4 to 11, and then we have the union, and here we have minus infinity to minus 4, right? So the combined solution is given by the union of these two intervals. So here we have the real number line, here we have minus infinity, here we have plus infinity, here we have minus 4, and here we have 11, right? So this interval, that is minus 4 to 11, is given by this region, right? Minus 4 to 11, and remember here both the endpoints are included, right? And here we have minus infinity to minus 4. So here we have minus infinity, and here we have minus 4. So this region is represented like this, and here we have a circle which represents that minus 4 is not included in this interval, right? So now, since we have to take the union of these two intervals, so the combined solution, or the union of these two intervals, is given by minus infinity to 11, right? Because first we go from minus infinity to minus 4, and then we go from minus 4 to 11, right? So when we combine these two intervals, then we can write the union of these two intervals as minus, here we can write minus infinity, and then we have here the last point is 11, and 11 is included, right? So the union of these two intervals is given by minus infinity to 11. So viewers, the solution of this inequality is given by this interval, that is from minus infinity to 11, right? And here we have obtained this solution by combining these two intervals, that is by taking the union of these two intervals, right? And this interval can also be written as x less than or equal to 11. So this is the final solution of this inequality. So here it is important to note that the equality holds when x is equal to 11. That is, we have a mod of x plus 4 is equal to 2x minus 7 when x is equal to 11. So let us substitute x is equal to 11 in this equation. So we have mod of 11 plus 4, and here we have 2 times 11 minus 7. So this is a mod of 15, and here we have 11 times 2 is 22 minus 7. So mod 15 is simply 15, and 22 minus 7 is equal to 15. So here this is a true statement, right? So the equality holds when x is equal to 11.